Unfortunately, I believe the critical ionization velocity page on Wikipedia is very poorly written. So I'm going to try to make the most of it as I can, because they don't provide any diagrams of any of this. They just show a picture of the outside of the bay of the space shuttle where they're shooting out plasma. Like, how is that a diagram of what's going on here? And I also looked it up on Google. I typed in critical ionization velocity, and basically there is no information on it whatsoever, no diagrams, no nothing. So I'm going on a wing and a prayer. Basically what I think they're trying to say is you have a gas, obviously the molecules have a certain velocity they travel in, and this is, the energy of a moving body, or the mass, and then the velocity, the kinetic energy of it, has to equal the ionization velocity, which means the amount of energy it's moving has to equal the amount of energy required to ionize the gas. In other words, it means this gas has to be traveling really fast in order to ionize. Just so you know, hydrogen automatically has a really fast, it travels really fast in the air, but its ionization velocity is 50.9, 10 to the 5 centimeters a second. That's what's written on the Wikipedia page. But of course, we all know that translates to 1 kilometer a second. So basically, a hydrogen atom, or should I say gas molecule, is traveling incredibly fast, 1 kilometer a second. Helium, that ionization velocity is 34.3, neon 14.3, hydrogen 14.1, carbon 13.4, and oxygen 12.7. Now, I think there can be a lot more added to this when it comes to stellar birth, because I think what they're trying to say is, if you have a gas, and of course it has those moving molecules in it, it's going to be neutral, it's not going to be ionized. But if you take the gas and you propel it through a tube of plasma, if you can propel it fast enough, that gas will ionize eventually, if it gets to be fast enough. And it will recycle back into the plasma and then provide it with more plasma as it goes through. And any additional energy that you give to the gas to propel it forward will just be going to directly ionizing that gas. It won't be towards making the gas go faster. Because what happens is that gas becomes plasma, and then it succumbs to electromagnetic forcing, meaning electromagnetism takes over and you can't really control it all that well. Now,